Privileged to introduce our today's speaker, Dr. Souvik Chatterjee. He works in education team at Mathwork, based in Bangalore. He is advocating computational thinking and model-based product-oriented interdisciplinary approach in research and education partnering with universities across the country. He is recipient of the Best Thesis Award, Best PhD Thesis Award, and Young Scientist Award from International Society for Energy and Environment. He worked in University of Illinois at Chicago as postdoctoral associate and at Enterprise Work Chicago as strategy consultant for commercialization of academic innovation. He has co-authored multiple journal articles, book chapters, and is co-inventor of 2 US patents. He completed BE in Mechanical Engineering from Jadavpur University and dual MS PhD degree from Jadavpur University and Virginia in Technology. Thank you. Thank you, sir.
Thank you, madam. Thanks, sir, for the warm welcome and thanks for inviting us. Good afternoon. Thanks, everybody, for joining in. And again, what we'll do, am I audible? Do we need the mic or you can hear? Yeah, thanks again for joining. Post-lunch session. So let's try to keep it interactive so that you don't fall asleep. Of course, we'll do some hands-on activities after this. So we'll probably do some 1 hour, we'll see around 1.5 hours of things, and then we'll probably go to the lab and do. Oh, I've been instructed to stay on this side because of the so yeah, the idea of we'll talk about a little more about these. There are two important things here, right? Big data analytics and green technologies. So we'll talk about both of them. You've heard about me about him. So my background is in mechanical, but then during PhD I did a lot of these data analytics bit. So data analytics, which we now call everything has gone into machine learning, deep learning terminologies, but there has been data analytics forever, for a long time. This is not new. Green technologies, we'll talk about renewables, a little bit of things, and my colleague Dr. Dave will be coming tomorrow. He will be talking about batteries from the EVs end of things. He will talk about something of digital twins of batteries. So the battery bit that I'll leave out for him, he will do it tomorrow. But I'll talk about a little more about how do we model renewables and then how do we use data analytics for that, right? So I am currently in MathWorks. How many of you know MATLAB Simulink? Okay. Anybody has not used or heard about? Used will come later on. Anybody has not heard about MATLAB? More or less everybody has heard about MATLAB. Okay. So MathWorks is a company. MATLAB and Simulink are the primary things. So we work in that company and we develop MATLAB Simulink, multiple toolboxes that comes around. We work with a lot of industry customers and academic customers. We'll talk about those things in a little more detail later on. But now, say for example, I understand most of you are faculties. Anybody research scholars? I see some of you are research scholars. Anybody undergraduate or research scholars? PhD students? Nobody? PhD students, yeah. Okay. So if anybody are facing any troubles later on, feel free to just catch up. We can discuss later on your problems and things. Okay, so yeah, we are from MathWorks, and just to give a context of the platform is MATLAB. MATLAB is the primary one that came up, which is like this sort of a scripting platform, right? So how many of you again have used Simulink before, and how many of you has MATLAB used before? So maybe just MATLAB. How many of you have used MATLAB? Okay. Some, can anybody just 1 or 2 sentences where you have used what? Yeah. Control systems. Power systems. Anything else? Image processing.
For electronic sensors.
Okay. Anything else? AI, okay. Anything else? I guess you are covering mostly everything. And the applications can go in multiple areas, but yeah, power systems, electronics. There are other things we do like pneumatic systems, thermal systems, all those things are there. But that's a MATLAB. Simulink, I guess how many of you use? Power systems will definitely, controls definitely. So just to give the context for people who have not used Simulink, Simulink is this block diagram based approach. So MATLAB we do scripting and Simulink we do block diagrams. So we'll cover both today because so I won't go into like basics of MATLAB Simulink, those are not part of the things. But with the examples we'll do, you'll see both these environments. And when we go hands-on, you will also use it. I'll share certain files, we'll be doing certain things there. So Simulink is block diagram. On top of that, there is something else we have done, is SimScape. Anybody has used SimScape? SimScape power systems, I think you have used. So those are like more component level design. So if you have something like a motor or something like say a DC motor, so you bring up components like a resistor, capacitor, connect them like you draw the circuit diagram, and then you simulate that, right? So that's the whole idea of SimScape. So we'll see those as well. Ultimately, at the end of the day, the whole thing is a modeling platform. So we do different type of model-based design, which is simulation of the whole system together. And also we can do very simple things like ODs, PDs, programmings in the MATLAB platform. So one thing that we also do with faculties is, create interactive curriculum and virtual labs. We have a lot of this full-fledged curriculum for say control systems, power systems. If anybody wants that, let me know, we can share those scripts. Those are for teaching concepts in a little interactive way. So that is more, that uses both MATLAB Simulink. It's sort of tool agnostic. It doesn't matter what tool we are using. So that's the two major platforms that we talk about. And I think in terms of whom we work with a lot of these different industries in different sectors. So aerospace and automotive are the two biggest areas. So we work with all these EV companies, the renewable companies, say for example, ISRO to NASA, HAL, all of them in terms of different model-based design. So what we call model-based design is modeling the whole system first of all, and then we integrate with the hardware, right? So integrate with the hardware means there is this concept of once you simulate everything, then you dump the code on the hardware. Okay, anybody works with any hardware, specific hardwares? It can be an Arduino. How many of you have seen an Arduino or worked with Arduino? Okay, right, Arduino, Raspberry Pi, right? So you do some modeling and then you integrate with an Arduino. So you connect the Arduino to the laptop and then you change something in the model and then you'll see that thing changing in the board. So that is one bit. The other bit is you don't say if there is an automotive application, we don't want a code or a model running in the way, right? So what we do is we dump the code on the hardware because it's the validated code. So once we develop like some control algorithm or something, we dump it on the hardware. So we call it deployment. That is one big aspect as well. So it can be with say NVIDIA boards, Intel boards, there are Texas Instruments boards, multiple different type of boards. And we integrate with all of them. So whatever we develop in terms of algorithm, we dump it on the hardware. So then you can use the hardware for real-time application. That's sort of the whole system. So, I mean, of course, in academia, we focus on different verticals and we go very deep. And when we do an end-to-end application, like if somebody is building a car, right? Imagine a car cruise control system, right? Have you seen cruise control in car, right? So you set up the speed in a car and the car goes on its own, right? So now if you have to develop that, so what do? You basically, anybody can say how will you develop, say if a cruise control is there, right? If you have a hill in front and the car needs to go up, right? How will the car maintain the same speed? Like if you are driving, say imagine if you are driving, what do you do to maintain the same speed? Anybody? Accelerate. So now if you have to maintain the cruise control, or if you think about automated, I mean this is level 2 autonomous cars essentially. Which means it will maintain its own speed. If you don't press the accelerator, then somebody else has to, right? And that's a classic control theory concept there. So it will sense and then it will trigger. So say we do this on my algorithm and then we have to dump this algorithm onto a controller. So that deployment bit is also important, integrating with hardware and of course working in real time and things like that. Now if you have to make that a little more advanced, say for example, if you have to make an automated car, automated driving car, which people are doing, many people are doing in India also, many people are doing that. The whole idea is then there are other sensors coming into the picture. So how do you integrate that with a camera, with a LiDAR, all these different type of sensors. And nowadays people call all these systems, the mechanical bit is there, but improving on the software bit is also an important part. So that is there. Communications, electronics, energy production is one big area. So those are the things which will go deeper. I'm covering the ones which we are not going into deeper today. So like this, it goes on. So I belong to the team called Customer Success Engineering team in MathWorks. So we work with all these different teams. So we work with our people who are using MATLAB Simulink for different applications. Either it is in academia or in the commercial or government, all these sectors. So we do research collaborations, curriculum building, helping people to generate and create technologies and things like that. So now coming back to the green technology front, right? So that's what very important bit, and we'll go into a little more detail on this. From a company perspective, we are also decarbonizing MathWorks, which basically is we are making all our office sort of green in that context. So whatever we talk about, like reducing waste and reducing electricities and stuff, using renewables. So how do we do that? Of course, we are using MATLAB to optimize the usage of electricity in our home office. So those are some important bits that is important to note, right? So how we do that? Say for example, carbon removal. There is transportation. EV is a big area, and then one thing that we'll go a little more detail today is something called efficient buildings. So efficient building, and that's where comes how can we use data analytics to help in making efficient buildings. Now, what does it mean? Anybody can guess what it means just seeing the title? If we say efficient building or digital twin of a building, what does it mean? Any thoughts? Like if you have to make a building which is energy efficient, you can do it in different ways. Architecturally, you can make it, but what else? What can be done to make a building energy efficient? Any thoughts?
Air ventilation.
Air ventilation can be one.
Light.
Electricity demand, that's what, from an electrical modeling perspective, we try to focus on. Yes, anything else? Right, and there is things comes up which call it digital twin. So I'll talk about a digital twin of a building today. Tomorrow they will talk about a digital twin of a battery. Anybody knows what is a digital twin? Of course, the English word means something which is very self-explanatory. Replica of a simulation model. So there is one difference between, people define it in different ways also. But if you look into even Wikipedia, there is one important bit that makes it different from just a digital replica. Of course, it's a digital replica. So if you have this room, or if you have a building or a car or anything, we make a digital replica that is there. But there is one important bit which makes it a digital twin, which is there is a real-time data going from the physical asset to the digital asset, which means the digital model is updating real-time. Okay, so say for example, if we make a digital twin of this building, of this room, say, and then we have to make sure that digital twin, say if this door is open or more people are coming in, and then things are changing here, that needs to be reflected in the digital model. So it's not like a digital model is made and we keep it, and then we have physical model which is completely separate. We need to have some form of communication between the two. There are multiple ways people do that. We'll come to those details, but this part is very important. So the digital twin means it's a replica, but it's a real-time of the model. And then why do we need it? We need it because people use it for different type of applications. We get it real-time updated. That means it can also help in predictions. Right? It can help in prediction based on the real-time things that are happening. It can also help in something called predictive maintenance. That's another important bit that has come up. There is a big demand of this in the industry, which is about what it means is, say for example, there are all this air conditioning unit here, right? Now, if we create a digital twin of this air conditioning unit, and then imagine that there is a real-time information going from the digital model to the physical model, then what we can also do is we can predict something called the remaining useful life of this components, which means, like say for example, imagine that there is a fan in our house, right? When we hear the sound of the fan, and the fan sound is something wrong, we can say that this fan is wrong, something is going to happen, this will fail in say 2 weeks or something, right? That we can say because we know the fan, how it sounds. But imagine in a factory floor or in a compressor unit or some kind of a factory floor, where we don't understand the sound of the fan or any of these things, but we have a model created, and that model can distinguish between a healthy fan and a faulty fan, right? If you have that model, then if you have real-time information coming to that model can tell you that this fan or compressor is faulty. Correct? I'll just mention it one more time. So imagine, say for example, you have a model. Like say for example, the model is in your phone. Okay, I take the phone to a compressor running in a factory floor, and I listen to the sound of that compressor. And there is an app. This app tells us that this sound is faulty, and this compressor will fail in 2 weeks. Okay, if that happens, if hypothetically you have that model, then you can predict failures. And if you can predict failures, we can take care of it. So we don't have to change it after it gets damaged. It saves a huge amount of cost. Okay, so this is another example of digital twin, where you create these models, and then this model can help you to predict failures, to predict something called remaining useful life and things like that. Now the question comes, how do we create these models? That's the biggest part of things. Anybody has any guesses where this is leading to? What sort of models do we create for this? So that's where things like machine learning, deep learning, these things come into the picture. Okay. So coming to that aspect, if anybody has used machine learning, deep learning, or heard about, heard I guess everybody has, but use machine learning, deep learning, or using it for some applications? Yeah, for something?
So for prediction purposes.
For prediction, so you are doing something like this, okay. Yeah, so this is one big aspect of doing things in terms of, because we are doing data analytics at the end of the day. So how do we do take different type of data, create models based on that, and that's the bit of big data analytics which we talk about. It's okay if you have not used. If you are interested, we'll go a little more deeper with the example, one of those with some power systems examples as well. Okay. Now we'll come to a case study, and then we'll go a little more deeper on what this is happening. So this case study is from a company called Building IQ. Okay. So what it has is similar sort of what we discussed, is having a digital twin for a building. So as the name suggests, people are doing building with higher IQ, right? So the current building condition is going to the server. Current building condition means you will have sensors around buildings, which means the load thing, how many people are there, how much energy, how much electricity is being consumed, all those things can come in. And then comes in, if you do an optimization program in these things. Say for example, if you have to optimize the energy condition in a way that what we want to do is we want to reduce the amount of electricity we consume from the grid. Okay, so imagine that you have solar panels, you have batteries, you have all these different forms of energy, and then one big problem comes up is how do we optimize the flow of energy, which means ultimately what we want to do is we want to reduce the amount of electricity we are consuming from the grid. And then we improve the electricity consumption from batteries, but then we have to charge the battery at some point of time. We need to have the solar panels. What will happen if it's a cloudy day? So all those things, if we take into consideration, what happens, right? So this is a case study from US, so that's why they have the energy fluctuation. Cost of energy is also fluctuating throughout the day. But the whole thing comes to the point of, if you have solar panels, if you have electricity coming from grid, if there are inverters, how do we create a system so that we reduce the amount of electricity we draw from the grid? Okay. So that's what these people use. And then the result that we got is, say, what we call here is traditional energy management system. This we are calling smart energy management system. When we are saying smart energy management system, that means it's an optimized one. The traditional ones is we are not using any optimization algorithm. The only thing we are using there is something called heuristic measures, which means, like, say for example, during the daytime we'll have the solar panels, right? And then if it's a cloudy day, we'll use from the battery. So something from common sense we are using where to go from. Now, what happens is, this is the comfort bound, so we are maintaining the temperature in this zone. Typically during the building, people stay in these hours. So that is the hours we want to keep the temperature within the comfort zone. And then this is what is happening in the traditional one. We are keeping this, And in the optimization one, you see that the comfort bound is this, but we are not keeping it uniform. It's changing based on certain all these other parameters. So that's where when we are doing the optimization algorithm, it's not onto us where we will use the electricity. The algorithm will dictate where to use the electricity. So we are using that optimization algorithm. And it shows a big thing in terms of electricity bill reduction for this buildings to be 25% less. So of course we see the output, right? Nowadays solar panels are also there in many cases. So how can we integrate all these sort of things together in one model, right? That's where this case study comes into the picture. Okay. Any questions at this point? At any point, just feel free to raise hand if you have any questions. So now what we are doing in terms of like a smart energy management system is, instead of having static policies, offline data, and manual operation, we are changing that to a dynamic system. So the dynamic policies, based on how things are changing, it will change real time data and automated. So it's not something that we are saying, okay, from 8 a.m. the solar panels will be coming into effect like that, and then algorithm will detect everything. Okay. So that's where all this comes into the picture. So we'll go to this a little bit in the MATLAB environment now to showcase some of these things. So if you have not seen, this is the MATLAB environment, right? Now most of the example that I'm going to talk about, I'll just show you how it looks like, and then we'll come again back to it. So this is the model that we'll talk about is in the Simulink world, right? And these are certain, we'll come to the data analytics, but and optimization. So these are multiple things that we will integrate in one environment. So predictive modeling, optimization, and then the deployment option. So the deployment means when you are deploying into some hardware, or we can also create an app, right? Imagine that you have a dashboard where the real-time information is coming and we are predicting certain things. So all those things if we have to do. So in general, what comes up in this sort of a model is how do you integrate both type of data, engineering data, which is the power systems, the batteries, all these things, as well as something called business data, like how much cost is we are saving and all that. Because when we are doing an integrated model, both needs to be clubbed together. This is an important bit. We integrate two things. One is a data-driven model and one is physics-driven model. Data-driven model is this machine learning type of things, data analytics. And physics-driven models is where we use like power systems, controls, these classical theories where we want to use. And then the modeling and simulation, and then which algorithms work best, right? So those sort of things. So this is how, I'll just run it here now, maybe pause it. This is how things look like in the Simulink world, okay? So Simulink world, you have all these blocks. So we use these blocks for each of these concepts. So this is the electrical grid, the variable load, the solar array, and the storage system, which is the battery. So we can use all of these blocks like that. So what we are doing here, if I just run it, so this is the electrical grid you can see here. This is the variable load. This is the load we are giving in the solar array. Here we are also giving the input, whether it's a clear day or a cloudy day. And then this is the battery, the energy storage unit. So you can see here this clear and a cloudy day. Right, so these are all these blocks. So like the way you will draw circuits, we also draw it inside here in the Simulink world. So now I'll go to the Simulink platform a little bit. Right, how do you call Simulink from MATLAB? Anybody who has used Simulink? So say if I write Simulink here, okay. So one thing with for people who have not seen Simulink or seeing this for the first time, anybody seeing Simulink for the first time? Okay. So what I'd suggest is, if you open up Simulink, there is a thing called Simulink on-ramp here. So this is a course you can do. All these courses are free and you can do it hands-on. So if I click on more here also, you will see these are some Simulink-based courses which are already there when you launch it. So say Simulink on-ramp, control design on-ramp, there is SimScape, circuit simulation, power electronics, and power system simulation. Each of them are like 1 hour, 1.5 hour type, and these are all hands-on exercises. So if you want to do something like a motor control or DC-DC conversion, these sort of things in Simulink, feel free to go through or any of these courses. So these courses are again hands-on materials and self-paced. That means you can take your own time to complete it. You get certificates also at the end of the day. And so what I would suggest is if you're new to Simulink, just go to the Simulink on-ramp course first, so then it becomes easier. Right, so if I just, what I'll show is I'll go to the, like some simple Simulink in the beginning. So if I go in the library browser, basically, you will see there is a lot of different type of things in this library. That includes things like control systems. So if I go into Simulink basics, you will see they're continuous. So say for example, if you want to do some integration operation, you can use the integrator block. So these blocks we can use and then we use the system. So PID controller, if you have a PID where you want to have a plant and the controller, then you can use this as well together. Now say for example, how do we use it? I mean, just to show you a very simple thing, you can drag and drop. But say for example, if I want to do a sine plot, we can just use something like right here sine, and then we can plot them through something like scope. We can just connect them. So this is super useful in that way because we are not writing codes and stuff. So you can just go to the scope and then run it. You can see these things running. If I want to add some random number to it, you can just click on here, add random number, click one, add sort of a block, and then connect them together. So these are some, I mean, just easy ways to get started and just know the platform, right? So here, now if I click on the scope, you'll see some random number is added to the Simulink block. So like this, you can just keep on exploring this. You can do integration, control stuff. The one that we were showing you is something that uses another platform called Simscape, which is on top of this. So I'll just again go to the library browser. So if you go here, inside this, there is something called Simscape. So if I go inside Simscape, what happens is if I go inside foundation library and then electrical elements, you can see that the electrical elements are there. So say for example, all these things like resistors, inductor, transformer. So we can use these components, connect them, right? You'd like to draw the circuit diagram, you can connect them and then simulate them. You can change the parameters and simulate them, right? That's the whole idea here. So this is useful. I mean, like that, we can do interdisciplinary models as well, like the mechanical components. And if I go into the Simscape electrical bit, there are a little more advanced type of elements here as well. Say for example, this this bars, and you can see a lot of different things which are there. So based on that, what we need, we can use. So just to explain this Simscape component, because most of the things we'll do, I mean, tomorrow you'll see more about this Simscape as well. I'll show you one more thing here. Say for example, this is a DC motor. Yeah. So I'm just using one more model here. Say this one here, there is a, okay, this is the ID, but I'll just use this. This is one model of a, you can see here, this is a DC motor model of a Simscape. So I'll just going step by step. So before going to the complicated one, this is a DC motor model. So you can understand which block, what is this? Register, this one is where the machine is, the motor is coming into. So you have the electrical to mechanical converter, right? And then we are using some torque, the sensors. So everything blue is electrical, everything green is mechanical, right? So we are just so some things to note here, when we use a Simscape block, we use something like this. This is called a solver configuration block. So this solver configuration block helps us in giving some details about which solver to use. Like if you have a model of a whole building or a car, it might happen that you might need to use a different solver for different areas. So that's why this is useful, but otherwise in SimScape we need this. Anybody knows what this block is, if you have used SimScape? So this one is called Simulink to physical converter, because Simulink, the concept of Simulink is it's a mathematical language, right? So you can do integration, differentiation, whereas SimScape is a physical modeling approach. So if you see here SimScape means all this colored stuff. So these are physical components, and this is an input. This is just a ramp velocity input. We are giving an input. How does it look like? If I have to see this, what we can do is I can put a scope here. And then if I just connect this here, you can see this to be connected. So if I just run this and then look into this scope, so this scope is just a input, right? This input we are giving. Now this is a Simulink block, this is a Simulink block, so we can connect them. But every time you have to connect a Simulink block to a SimScape, like if I delete this block, you won't be able to connect these two, because this is SimScape and this is Simulink. So that's why we need something called a Simulink to PS converter. So that means Simulink to physical signals. So this is the one by which we are convert this. These are all references, and here we are plotting the output, right? So for this motor, we are just plotting the voltage here, the torque here. So you can see here, and we can see the output that has come out. Right. So this is very classical. A DC motor model. So in the SimScape thing. So SimScape you can explore more. There are multiple things. Now, say for example, imagine you have this motor, and then you want to control this motor via a PID controller. So you can put a PID controller in front of it and then tune the PID controller and go forward from there, right? So these are things which you can do. Now I'll come back to the example that I was showing. So this is the model of that building. Now in that building we have those grid, the load, the solar array, and this energy system. So if I run this now, let's run this. This model is also there. I'll share this model if anybody wants. So what you can do is you can use this model as a starting point and change anything as needed. Okay. So let me find out the plot for this. So imagine, just look into the things that we are doing here. So we are doing for a clear day, and for now we are not using any optimization methods. So I'm just running this, and then also Simulink is a time-based solver, so we need to give the time here. So this time is stated here. So now this is the plot of all the output. So let's look into this a little more detail. So the top one is the microgrid voltage. Here we are seeing the power so the yellow one is the solar panel. So the solar panel, you can see the power going up during, so this is the time of the day. This is the state of the charge of the battery, and this is the cost of electricity. So you are seeing sort of outputs of all of them, and then the red one is the grid electricity, the power we are drawing from the grid. So now this is how it looks like, and this is a heuristic, so this is not optimized algorithm. So you can see here that at this point the cost of electricity is high, but we are also using a lot of power from the grid at this point of time. So it's not cost effective in that sense. And then during the solar panel is getting the power during the daytime, like this, right? So now say for example, if I change this from clear to cloudy day, we can change this. So what happens when we change this? The irradiance profile changes inside here. And then if I run this, you can see that the plot is much more changing, like fluctuating, because it's a cloudy day. Things are changing, the solar panels are changing, so the red, this yellow is changing, and things are different here, right? So now, say for example, if I change this from a heuristic to an optimization algorithm, so I'm just changing here. So you can create this dashboard, by dashboards like this. Of course, when I'm changing this, some things are changing in the model. That something is basically a switch case algorithm, a state flow sort of an algorithm, that if I change this, then it will use an optimization algorithm. So that optimization algorithm will come in a bit. But for a dashboard, you can create something like this for presenting purposes. And then if I do optimize like a cloud optimization thing for a clear day, optimization will take a little more time. But let's see how it looks like. So this is the cloud. Instead of the cloudy day, maybe I'll prefer the clear day because we can compare it better. And we are just plotting everything together in this scope here. So, I mean, people who want to build this type of models, I mean, there is a step-by-step learning curve, right? So you can start with those on-ramps. There are multiple documentation examples. These models we can also share. So now if you look into this one, this is the optimized algorithm here. You can see here that this red one, it starts taking from the grid itself in the very morning, and then the battery gets charged. The battery gets charged at this point of time. So it does some dynamic changing stuff. What we are doing is we are also monitoring the cost per retail, and that's what this number is actually getting lowered when we are using an optimization algorithm. Now what we are doing in the model itself, so I'll probably go here. So I think we have gone through this. So just to, yeah, so these are, if you look into inside the model, these are two things that are there. So we have created this something called state flow. In the state flow, we can create these type of different states. So when it is, what it will do where. So we can say, okay, during the daytime, you charge the battery between these hours, you take electricity from solar panels at this hour. So those things we can set up in this state flow chart. And this one is the optimization algorithm. So when we are changing in that, I'll just go back. So when we are changing in that that bubble thing, where we are changing from optimized to heuristic, basically this case is getting flipped at the back end. So either it is taking the top route, which is the heuristic one, or it is taking the optimized algorithm route. So if it's doing the optimized algorithm route, if we go into the optimization algorithm, so we have created this function here. This is a MATLAB function where we are doing an optimization algorithm using something called an fmin-con solver. If you have the objective function and constraints, you can do that. Anybody has done optimization in MATLAB before? So there is again, I mean, we have an optimization on-ramp course where you can learn about optimization. That thing also we'll talk a little bit when you do hands-on, like how you can do those things. But you can do any kind of this optimization algorithm. So in a typical optimization algorithm, what will happen is you will give input of, say, something like the cost objective function, the constraints, and then you choose what type of algorithm to use. There are multiple algorithms. There can be like genetic algorithm type of stuff, as well as fmin-con, and then it will give you the solution for that optimization algorithm. Yeah, so that's how this is done. And coming back to the sort of the ultimate result that we found out, here if we see that there is some cost optimization, and if you see here the grid usage between at the top here, so between so the red one is optimization algorithm, right? The red one is lower, which means the optimization algorithm is giving less power, it's drawing less power from grid, which is leading to less cost of power. So that is the sort of the example, and then that's how you can do the models in SimScape. Of course, there are multiple intricate details of how do you do that, and that goes to like how do you model solar panels, and for that we can have some examples which can help you. Say, for example, this is a very simple SimScape example for how do you model solar panels. We have the solar cells. This is there in the example also as well. This is, you have the solar panel block, and then you just get so this is something called a shading in solar panels. Those are sort of things which we can do as well, right? Any questions on this? Anybody working on these type of things, this energy management or optimizations of energy management? Okay. But bits of it, if you want to use any of these, feel free to explore whatever can help in this context. So just to go a little more detail on the optimization, this is how the algorithm is structured. So this is the theory behind the optimization. So we give this objective function, these are the constraints, and then this is how we set up the code. I mean, this is a little old now. Nowadays, we don't have to write codes also for optimization. there are some ways by which we can do things more easily inside the MATLAB platform. Okay. Coming to that, just maybe showcase one thing here. So we'll go to the data analytics bit now. So I'll just go over to MATLAB here. The thing that I'm using is there's something called new live script here inside MATLAB. Anybody has used the new live scripts? Okay. So in general, if you save a MATLAB file, what file format is it? .m, right? So this one, if you save, it will be .mlx. .mlx. Now what does that mean is you can think about it to be like a Word document with MATLAB coding. And that's where things becomes a little easier nowadays. So say for example, if I'll just show you, and we will try to do some things during the hands-on exercise as well. So here we can write things, so we can shuffle between text. So say for example, this is a sample. If I just write, this is a sample code. And then I'm just shuffling to the code mode. I'll just create some random data now. Say for example this, and then some y equal to sine t, and then say for example plot t comma y, right? And then if I just do this, you will see that the output is coming here, right? Now say for example, if I have to make this a smoother curve, you'll see where I'm going into with this. So if I go say write increment equal to say 0.1, and then we put here increment. So that means we are just giving this increment as the step value, right? So instead of start having the increment to be 1, we are giving 0.1. So that means we have more number of resolution is more, and then we are getting a smoother curve. Now the point comes, if I want to make this something that we can change while we go along. So that's the advantage of live script. So what we can go here is, instead of this 0.1, I can put here and go to insert, and then you will see there is an option called control. Inside the control option, if I go to something, there is multiple options. So say for example, I choose a numeric slider, and in the numeric slider, we give the minimum value to be say 0.1, the maximum we can give to be 1, and step value we can give to be 0.1. Oops. The step value we can give to be 0.1, and the default value say 0.1. So what happens when we do this is we can change this slider, and you will see things are changing at the output. Okay. So this is, you're changing, and then you will see things are changing. So you can use this sort of interactive controls things to do, right? And that makes things a little easier and also interesting like that. Like there are multiple controls, like you can put dashboards, buttons, choose things. So basically you make coding easier essentially. You don't have to write too much of codes. Now another thing that comes up here is, if I'll do a section break, and then say for example, now we are gradually going towards some data analytics bit as well. So for the data analytics part, say for example, we have some outliers in here. So what I'll do is I'll put some intentionally outlier inside. So this sine curve is between -1 and 0.1, right? So I'm putting say something like a value of 5, and then we say plot t comma y, and then if I run this, so you see that now the sine curve has this outlier. Okay. Now if you have to remove this outlier, what we can do is, instead of going just writing codes, you can go to this thing called task. Task is a very interactive, easy way to do things. You don't have to write codes again. It's a graphical user interface for doing certain stuff. So if you click on task, there is a lot of different tasks. You can see here there is also anybody uses Python for anything? Okay. So if you're using Python for say some data analytics or something, what we can do is we can run a Python code from here as well. So if you are using deep learning for Keras TensorFlow, these sort of things, we can use those models here. So you can use a Keras TensorFlow for a load flow analysis of something. We have an example for predicting the state of charge of an electric vehicle battery using a neural network deep learning. So those are cases which are very important and very upcoming nowadays. So those things also can be done pretty easily through this. So there is run Python code, plot. The one that we are looking for is clean outlier data. So if I click on this clean outlier data, so we select the input data here. So our input data is, I think for now it is just y. X-axis we can keep t. So this is our x-axis. And then it says clean, fill outliers, linear interpolation. So for example, if I click on remove outliers, so it will find out that this is the outlier, and due to some thing. This is cleaned out, right? It has found out some different value there, but we can change the algorithm, the threshold values and things like that here. So this threshold value, if you change the threshold value, you can see all these things will change. Basically, you have to increase the threshold value to make sure that this outlier is identified. Right, so this is remove outliers, but if I want to fill outliers and then use linear interpolation, we will fill it by some value. So like this we can do, there are multiple methods. So if I want, instead of linear interpolation, if we change the previous value, then basically it will take the previous value for that interpolation. So like this, we can just do things, and then if you click on the show code, the code will automatically come up. We don't have to write the code, okay? So basically, if we look at this end, there is an option of controls and code only. So if you click on controls and code, then for whatever we are doing, the code will come up at the bottom. So this code you don't have to write, it will automatically come up. And that is true for all those tasks. So if you do missing data, we'll do some tables and calculating mean, median, mode, statistical features and things. And that is true for optimization as well. So that's the advancement in optimization that is also there. Right, so this is a very important area what you can use this, using these tasks. This is there from last 2-3 versions. Yeah, it should be there. I mean, some of the things are new, like running Python code is a new one, which is for this version. But say, for example, cleaning data, it has been there for the last 2 years. Yeah, it should be there. On that note, actually, one important thing to note is everything is available in the MATLAB online version as well. So if you don't have MATLAB installed, you can just log into MATLAB online. This is hosted in AWS, and you can do almost everything, all these things, as long as you have a stable internet connection, you can open MATLAB online and you can do all these things there as well. You can do Simulink, SimScape, the power systems, control systems, those things as well. Right, so this is the online version, which you can do pretty easily here. Yeah, I'm using the hotspot, so it might be delayed, but that's another thing. Okay. Actually, this is an extension of something called apps. So if anybody has used the apps before, so apps has been there for a long time. So there are apps like, say, curve fitting, optimization. This is PID tuner. What it does is, if you have a plant, it will linearize the plant and will find you the value of PID. So signal analyzer, instrument control, there are different all these apps. You can create your own apps as well. So people create their own apps, and if you create your own apps, you can share with people who do not have MATLAB. So you can create people create their own GUI and even sell that to other people. We don't have copyright if you create an app and sell it to other people. Those things are also possible. Then there are AI, which will come in a second. But then, say for example, tomorrow I think they will talk about the battery builder apps as well, robotics and multiple other things. So these apps are also there. Now what we are doing is we are bringing these apps inside the Livestream platform. The apps are there separate as of now, but the idea is to bring them within the Livestream environment, and that is what live task is. Okay. Right. So another thing that comes up here is maybe the optimization thing that we have been talking about. You can also do things like optimization through the live tasks. I'll just show one of that example as well. Like say, this is a very simple problem where we have these, these sort of objective functions. So this is the objective function. These are the constraints. So we are defining the objective function and then creating the bounds and constraints, and then we are using the optimized live task. So here again, in the previous example, I was showing the codes. So that example was built like 5-6 years back. Now we don't have to write those codes as well. We can use this optimized live task, choose which sort of a problem we are solving. So this is a quadratic problem. We give the constraints, the lower bounds and linear inequalities. We choose the solver. So here we are choosing F-mean form, but you can choose other optimization algorithm solvers. And then basically once we run it, it solves the problem. Okay. So these are some easy ways by which you can do optimization algorithms as well. Okay. Okay. So now what we'll do is we'll move ahead. Any questions on this front?
So when we are performing the black diagram of any real-time application, just by changing the coding, we can able to control that.
Yeah. So we can change the coding and you can, that's the whole idea. Yeah. And then, yeah.
Most of the IGP transaction paper, even though we are telling, we could not get the output what they are getting.
So I mean, nowadays also for the IEEE transactions, you can ask for their models or codes through GitHub, because then that can be run also. Yeah, because I mean, some of the things what we are trying to do is from the GitHub directly running something in MATLAB online.
And we cannot able to find where the mistake is. That is the.
So for that, there are some ways, like in a MATLAB model, there is something called a profiler. Profiler or debugger, these are things by which you can find out where the bug exists in the code. So profiler, at times when you are running a model, you might see that it's taking a lot of time. Say for example, if it's taking a lot of time, if you use a profiler, you can find out for which part it is taking time and then just look for that. There are ways by parallelizing, you can parallelize as well as multiple cores, and through that you can find out where the problem is. Debugger also helps you to understand where the error lies. So these are some ways which can help. Okay. Now what we'll do is we'll come a little more in the big data analytics part. So the big data analytics part, and then we'll use it for a load forecasting example. So the big data analytics part comes in the front of where we use the database models, right? So when we have these models, where we are using as like you are modeling a turbine or a solar panels, you can generate data through simulations as well, but you can also generate data from sensors. And where this data analytics come into the picture is whenever we have a lot of data. Okay. Now this data bit thing is like people were using machine learning, deep learning in 1950s as well, but now data is becoming something which is easy to access. Of course, if we do not have the right data, because people are making data private and things like that. But if there is data, then there is a lot of things we can do with data. Now the important bit is there is a saying in this data analytics world which is called, garbage in is garbage out. If your data is wrong, whatever model you are getting out of that thing is also will be wrong. So it's important that you get the right data. Now what can be data? It depends on what we want to do, right? So what we will do is we'll do a load forecasting example. So for load forecasting, there can be different type of data. We can take the temperature type, temperature things, temperature data for temperature sensors in different cases. How many people are there? This can be one. There can be different type of these, predictors. We call it predictors in the data analytics world. Now, once we get the data, and the data is also timestamped, right? So, say for example, when the data you are getting, like after every 5 minutes, 5 seconds, this sort of things is also critical. And the data can be anything. It can be numbers, it can be strings, it can be all those things. So you get data from a lot of these things. So the first step is getting that data. Now when you have the data, another important step is where to store the data, how do you get the data. So for storing the data, people use servers. There can be multiple different cloud servers. You can store in your own space as well. But an important bit after getting the data is pre-processing the data. Okay, anybody knows what pre-processing data means? Any thoughts? Set up the data as per the requirement. We did a little bit of pre-processing, which is removing outliers. That can be a pre-processing. But make sure when you are removing outliers, you don't remove the important features. So that is something to take care of, right? So that is the second step. So when we talk about a data model, data analytics model, these are all the steps we need to do. We can't just keep on doing one thing and that will help. So you do the pre-processing bit. So as I mentioned, so you find out the relevant information from the data. So we'll see what that is. The next step is, this is the step what is we call the AI. Because up till this, there is nothing AI. This is data analytics, what you might have done in any statistics course that, or even before when you were doing like finding out mean, median, those other things. Developing predictive models is where things come in the form of machine learning or deep learning. Okay. Now there can be machine learning models, there can be deep learning models. Anybody knows the difference between the two? What is the difference between machine learning and deep learning? If you have seen about this. Okay, so I'll give you a sort of a rough idea about all these things. The whole idea of this data-based analysis is you use the model for prediction, right? Without that, all this AI, it doesn't make sense. We are predicting something. Now, imagine, I mean, nowadays people use it for everything. Say for example, where do you use, anybody can think about any example where you are, I mean, you are not doing it, but you are using machine learning, or some tool you are using, they're using machine learning every day.
YouTube and Amazon.
YouTube, Amazon, everybody. If you think about Gmail, Gmail categorizes some of your email as important, some of your as non-important, some as spam. How does it do that? It's a typical example of machine learning. It's learning. So we have to have a data set which is something we call it trained data set, which is a data set which knows what the response is. So say for example, I am telling Gmail repeatedly that this email is spam. Then after we do that, it will learn and then it will put it to spam, right? So that is that bit of things. YouTube, like if you're watching YouTube, it will give you similar type of music predictions. That is something where you are using AI. And then there can be multiple other things, Netflix and all those things are there. But now the difference comes in the form of like inside machine learning, we use something called a feature extraction bit. Like what that means is, say for example, another important example is object detection. In the people who do image processing and computer vision, they use a lot of this object detection. Like if you use Facebook, it tags a box around your face, right? How does it know that this is a face? This is object detection. And when people are doing automated driving or robotics, these type of examples, they use these things as well. Now say imagine if I have to have an algorithm which will identify that this is a mouse, right? So how do we know that this is a mouse and say this is a bottle? If it's as a person, as a image processing person or a computer vision person, somebody has to know that. What they will do? Any thoughts? Like we know because we know, but scan the picture, compare. So mathematically, these are because of different parameters. Say some tortuosity, cylindricity, it can be the curvature of this. So you have to find out some features. How many edges are there, the color thresholding. These are different techniques we can do on both of these and find out the difference. So this step of finding out these features, when we do by image processing for this or by signal processing for this, that is called machine learning. In deep learning, we don't do that. We give all this work to something called a neural network. We put all this data information to something called a neural network. The neural network is created in that way, that it can do that feature extraction bit as well. There are different types of neural networks in the world. People use, if anybody has heard about CNN, convolution neural network, that is for images. For these type of load forecasting analysis, we use something called LSTM, long short-term memory. Because it's in a time series. Very simple reason, it's a time series analysis. It has a memory. So that's the difference between machine learning and deep learning. Deep learning, we use this neural networks. Machine learning, we use this feature extraction technique. The rest of the things remain same. Like all this step and this step, this remains the same. It's only where this part where things are different. Okay. So yeah, these are most cases for this type of load forecasting analysis and all, we use signal data, right? So it will be time series type of information. So it's not imaging, but we were working with somebody who were finding out defects in wind turbine blades. I'm just going to the renewable sector. So in the renewable sector also, image processing is a big area. So people were trying to find out defects in wind turbine blades through like deep learning, right? So for how that can be done is we can have, like, say for example, 100 images of defecting turbine blades and 100 images of normal blades. And then we create a model with both these data sets. And then when you give a random image to this model, it can identify which is a defective and which is a healthy one. So these are some of the examples that we can do. On that note, in the AI world, what is the most recent thing anybody knows of that has come up? ChatGPT, hearing somewhere, right? So generative AI. Generative AI is also a big area that has come up. So on that note, I'll just show you one thing. If you are using MATLAB, there is something called AI Chat Playground. So this is using ChatGPT-4 at the backend. This is also very, very interesting, and you can use it as much as you want, but with a pinch of salt. I can't guarantee everything that will come is perfectly correct. So here, once it come up, you'll see. So on the left, we can write in plain English what you want, and it will write the MATLAB code for that in the right. So say for example, Anybody has any recommendations? We tried something on conditional probability yesterday. So, sorry? Yeah. You're saying something? Anybody? Okay. Say for example, write an optimization algorithm. Write a code for a non-linear optimization problem. I'm just trying out something. So if you just write here, it will, yeah, based on internet connection, it takes time. So, but simple things like plotting, if you want neural network code, machine learning, it will give it pretty clearly. ODE solving, if you want to solve a differential equation, PDEs, image processing, signal processing. If you want to take some time series data to Fourier series, there are multiple things like that. So those things you can just write here, it will give you the code. And you can just take the code from here. See, it has done that. So what it is, certainly here is an example of an optimization problem. So this is the code it has just generated now. So what we can do is we can just click on this, the code will come up here and you can run it here, the entire MATLAB code. So here what it has done in, this is where it has generated the function. This is called, now you can go through it in a little more detail and understand what this is. This is about defining the function, this is where it is using fmicon, things like that. So yeah, I think I stopped it in between, but say for example, we can try out, I don't know what we'll say, create a code for a load forecasting, and I think a bit of time, so I don't know, but you can try out this is a very, when we go to the lab, you can try out more. This will be more fun there. Okay. Yeah, so this is using the ChatGPT-4, which is the recent ChatGPT that is there. Okay. So now we'll go through this entire step now with one example. So taking the data, pre-processing the data, and this developing the model and stuff like that through one example. And then we'll head over to the lab and do certain things there. Okay, so this is the electricity load data from New York. You can find that data. It's a public data set. So if you want to try out with this data set, you can try out. So what we are doing here is first what we are doing is we are just downloading the data set. I have downloaded it earlier. So you can write a script to download it, but instead of that, you can just download it from the website itself. So once we have the data set, so now let's see what we are trying to do. So I have saved that data set here inside this mat file. So this is again an example of live script. So live script, you can go section by section and run this like that. So what we have is, this is our original data set. And now you can see how the data set, so these are different areas. So from different locations, we are getting the electricity for thing. For date, so this is the date, this is the timestamp. And then this is for different locations, we are getting the electricity load. Now, what we are doing is, so just to understand how this data set looks like when you are doing certain things in MATLAB, and this is something that you will do also a little bit at the, I'm just clearing all so that we don't have something from the previous script. So again, I'll run this. So this is the data that we are loading, right? This NY-ISO original. So this is how the data looks like. So every data that we load, it comes up here. So if you look into the data, this contains the date, and then this is the numbers, right, for different locations. So one thing to note is when you are handling with data, just remember how to handle tabular data in MATLAB, because then it becomes easier. Okay. So this is the name of the table. So what happens is, if I want to plot this column, so what you have to do is, I'm just showing you here, plot. So you say here the name of the table. So this is the name of the table, and you put a dot, and then inside the dot you will have all the columns. So this is one of the columns, and if I just do this, and then you will see that this data is plotted. So you can just name the table, dot, and that column. So that's how you access each of those tables. So what we are doing in this script now, So this is the data set. We are just plotting that data set. Okay. Now one thing, if you look here, this data set is not regularized, right? This data is 0, then after 5, after 10, but after 13, 26, after 16. So it's not a regular timestamp. When you are doing something with the data set, it's important to have it in a regularized timestamp. So that is the step that we are doing next. And for that, it's just using this simple command retime, and we can see how the time. And now we are giving it 5 minutes. So then you can see it just, so what it does is it does linear interpolation to find out the data as like that. So if you use this command, it will do that linear interpolation and find out the data as a regular timestamp. So that is what we are doing here. Now we are trying to find out some parameters inside the data. So we are using this command called find spikes. So basically we are finding out the spikes that we are getting inside the data. Okay, so this is now we are going to the pre-processing steps. We have accessed the data. Now we are doing some pre-processing here, finding out where are the peaks. And if you have some time series data, what do we need to do? Anybody knows? If you have to find out features, we might have to go to spectral domain as well. Okay, so like say for example, just to show this, this is one of these, right? The Y. So this is the date. So say for example, if this is the data set, I'll take one of these data set. Say if I just name it here. So this A is a typical signal data set, right? This one. So if I have to go to this spectral domain for this, we can go to this apps here. And then there is an app called Signal Analyzer. Because if you're using this load type of data, these are all time series data. And if you have to pre-process this and go to from time domain to spectral domain, you can use this as well. So we go to the Signal Analyzer domain, and here we am just, so this is that A variable. I'm taking it on the top, click on here. So you can see this is the plot. Now what we can do is, if I click on display and click on, so this is the time series data. But if I click on this data, so analyzer, we can go for pre-process here, and then all these, if you want to have like smoothing data, band pass, all this filter type of things, you can do all these things here. The other thing what we can do is we can go to the spectrum and find out the spectrum of this, which is, it will take the FFT of this and it will take you to the time spectral series domain. And this is probably something it's not coming up. Yeah, so these are the steps of, this is what we are doing in terms of some of the pre-processing steps. So we did this, and then we find out the spikes here. And then if you want to clean up the spikes, so we can, there is this command whereby which we are finding, like cleaning up it. Missing values, so these codes are there, but we can also use those tasks. So you can use those tasks and find out the missing values. So these are different type of things which you can do for pre-processing. So after that, I'll probably go over into the, so this is the load data, and then we are also getting the weather data, which is the temperature data. So same things we are doing for temperature data set. So the temperature data sets are different things we are getting. So these are the temperature data sets. Same things what we are doing here is getting the missing values and things like, so maybe removing the outliers, finding out the peaks, and filling out the missing values. So once we have done that, so I'll come to the model bit of things. That is the important part of here. Something is still running. Any questions while this is still running? I'll try to stop it. Okay, so now say after we have all the data set, so that's where this comes into the picture of, this is the load and the temperature. These are two things that we have got. The load is that electricity data set, and the temperature is the temperature of different locations. So those are things which we have got. Now these are the predictors. So there is something called predictors and there is something called response. So predictors means what are the input variables and response means what is the output variable, right? So based on these input variables, we predict the load, right? So that bit of things. So we create these predictors. Now what we'll see is, inside your, here you will see all those data set that are coming up here. So this is, say for example, the date, the load, hour, month, year, whether it is a weekend or a weekday, that can also be an important thing that is helping in predicting the temperature, dew point. So these are all important information, right? So these are the input variables. That is what we call predictors. Okay. Yeah, before going into this, is this helpful? I mean, if you want something else, we can talk about something else as well.
Sir, can you show how to load the data, sir?
How to load the data? What type of data?
It is in CSV file data, sir.
CSV file dataset. Okay. CSV file dataset is you can just drag and drop. So actually, let me try out something. We'll try out that playground thing. Write a code to import CSV file dataset. Let's say. Let's see what it gives. I think this is fair enough. If you give the file path here and then say read matrix file path, it will display the data. Okay. Yeah, these 3 lines. This will work. The other option is you can like if you have the CSV file inside this area, inside the folder basically. So you can drag and drop like this as well. This will also work. We can show with Excel files, but it will work with CSV files as well.
How to access a certain column or row in Excel?
How to?
Using a data.
How to, sir? Can you?
While I am working on math coding, so I want to access for certain column which is available in CSV file.
Okay. CSV Excel same, right? So let me just show you one example. I think that might be useful. I'll try to find out the data that I have. I think this is a Excel file that we have. This might work, yeah. So I'll go to one of these files here. So say I'm just going here. There is one file here. So say for example, this is an Excel file. So this file, it can be a CSV file as well. So if I just open this file, this is how it looks like, right? This file is very simple. There are two. One is a date and one is a this is a closing price, stock price. So if you have to take this data to MATLAB, you can just double click it here. So if you double click it here, it will open up like this. Okay. And after that, you can just import this data, or you can create a generate live script. So if I click on import data, it will already be there inside this. So I'll just again clear everything. So when you do clear all, this entire workspace gets clear. That becomes helpful. So now if I go to import selection and import data, what will happen is this data will come here. Okay. Now inside this data, if I click on this, this looks like a table. That's why I was talking about the table format. So all the CSV files or Excel comes here as a table format. Now inside the table format, you have two columns, right? So this is date and this is this closing price. So if I have to extract one column, just find out one column of it, what we can do is, if I have to find out this column, so know the name of the title here, this is the title. So what we can do is, we can say y equal to the name of the table. So this is our name of the table. So this name I'm taking from here, dot. Then if you create a tab, you will find all these properties will come. So these properties are nothing but the columns and some other properties. So one of them is date, one of them is this. So these two are the two columns. These three things will always remain. These are some properties of that Excel. So now if I choose Amazon, this AMZ and closing price, and then click on enter and then plot it, you will find that this data will come up. Okay. So the whole idea is, if you have a table and if you want to find out any particular column of that table, you just, so first of all, get that CSV file or Excel file, just import it to MATLAB. When you import it, it will be as a table format, and from the table format, just to find out the name of the column, and then you will get that. So you can save it to a different name. So it will be a one matrix, one column basically. Okay. On that note, actually, I'll show you some other things which might be also useful. So I think, yeah, there are these two areas, right? One is the physics-based model, which is in the SimScape electrical world, right? So if you have a model of something you want to do, so it can be something like a wind turbine model, you can do a modeling of a wind turbine, or say if you want to model of a battery, electrical system, power systems, you do that. And then if you want to use data analytics, we do it this neural network, machine learning, these type of things. Both of them you can do based on what you want to. And then the final thing can be deployed either as an app or to the hardware. So that integration with hardware or creating of an app. So I think what can also be helpful is, we have this list of things for different areas which are for teaching material. These are course materials. I'll talk about a little bit about this. So say for example, if there is something, if you want to know about programming with MATLAB, these are very simple things which can be helpful. Similarly, mathematics or maths for AI, the DC motor, how do you solve numerical methods? Then mass spin damper is probably not relevant for you. ODE solvers, signal processing, control systems, if it helps, we can. So this talks about a DC motor, how do you tune with a PID, linearize the PID, these type of things. So this is a circuit simulation. This might be useful for you. So these sort of things can be useful. And then deep learning. So the deep learning, machine learning, I think we just sort of touched upon today. We do like whole day workshops type things, but if you are interested, I think once you get started, you can do a lot of different things in this specter, right? So that is also, in the EV world, we have created a full-fledged sort of a curriculum on EV, which covers like power converters, the motors, and then some things like system level modeling, the thermal modeling of batteries. All these aspects are there, which if that helps, we can talk about. Yeah, digital electronics and so on are there. So I think, yeah, these things for the faculties, if you need for any of these things, feel free to just reach out. This is not there, like when you download the software, these are not there, but we can definitely share all these things. Okay, any specific questions, anything?
So power angle curve of generators.
Power?
Angle curve.
Power angle curve of generators. Yeah, I don't know whether we can do that through. If you're coming tomorrow, I would suggest asking to Dave, because he works with generators. He might help you on that. The person will come, he can help you on that. Yeah, so then another thing, important bit is, so if I go to matlabacademy.mathworks.com, so this is something that is also very important, you can go through. See, these are all courses which you have access to, and I think this might be very useful. So say for example, if you are new to MATLAB, you can go through MATLAB on-ramp or Simulink on-ramp, machine learning, deep learning, app building, reinforcement learning. These are all of there. Wherever on-ramp is written is like the basic level course. But if we go into say something like physical modeling, then you will see power electronics simulation, circuit simulation. I think from your perspective, all these are important on systems and power simulations. So all these are hands-on courses, and you get certificate at the end as well. So feel free to use this as needed. Yeah. So assessment here, there is no specific assessment, but once you do it correctly, it will move to the next part. So it gives you task, and if you do it correctly, it will move to the next task. Like this it goes. And at the end, it gives a certificate.
So is it available in MATLAB?
Yeah, it's available.
Because most of the students don't have the licensed version of MATLAB at home.
But they don't need. I mean, they can use their online and the Anand. I mean, so the thing is, most of the institutes who have the license, like the Anand Sagar here, they can use the Anand Sagar email ID to access, because the Anand Sagar I think has it, so you can use that. But yeah, you can use the online version. Yeah, I think just wrap things up in 2 minutes. Okay. Any other questions? I think for the MATLAB part I skipped through, but what I'll do is when we go to the lab session, I'll share some files and you will run along with us through it. We'll go through that in some sense. I think this is the model, just to summarize what we were talking about. We did not go into the machine learning, deep learning bit, because probably this is something that you are not experienced with, because machine learning, deep learning is another big area. The thing is, for those aspects, you don't have to know all the things also. You can know which algorithm to use and use that algorithm. So what we use is, inside the MATLAB platform, there is this thing called this apps, right? So inside this app, there is classification. So these apps are again useful. So say, for example, you don't know which algorithm to use with machine learning, you can try out all the algorithms and see which one is giving better result. Once you have the predictors and the response. So remember these two words, predictors and response. So predictors are the input things we are giving to a model, response in the output, right? So that's what it is doing. So if I just summarize that case study of the load forecasting, we are giving that data to the forecasting algorithm, and it is based on all these parameters. Say, for example, if it's a weekday, weekend, time of the day, how many people are there, what is the temperature and the load. So it's calculating the load, and then what we are doing is we are creating that app. So based on say, for example, if we have an operator sitting somewhere, they don't have to go through the coding. They will see just a dashboard where all these things are predicted. And then you can put that on the cloud. So we have a facility by which whatever app we develop, we can put it on the cloud. So you can just stream it somewhere. Real-time data will do that. So that is this thing that is happening here. Right. So this is how you can choose the forecast. This is how the app looks like. So, and we can integrate with the geo map as well, the satellite data and stuff. So this is one aspect, I think, what is very useful. On just to highlight on that, what we do is once we develop this algorithm, we use these forms to deploy. One is the app format that we talked about, and the other one is this. So if you are working with any hardware, like what we talked about, Arduino, Raspberry Pi, right? So say, for example, if I go inside the MATLAB home button, and then here you will see that there is this thing called add-ons. So if you click on get hardware support package, so you can search for the hardware you are working with. So it can be Arduino, Raspberry Pi, Texas Instruments board, or Jetson, NVIDIA boards, any of those boards. So you can search for the hardware, like all these are there. So say, for example, if you're Raspberry Pi, so you can install this, and then what happens is you can integrate you can connect the Raspberry Pi to the pin, and it will detect it. And the easiest hardware is our phone as well, right? So what we can also do is, once you have your Android or iPhone, you can install MATLAB Mobile inside the phone as well. And what that does, it will help you to access the sensors in our phone. All our phone has sensors, accelerometers, gyroscopes and stuff. So I guess what classic example we tell students also to create your own Fitbit. You can use this sensor data and just count the number of steps. It's a very simple algorithm which anybody can do. So like this, you can get all this hardware. So it can be an Android, Arduino, Raspberry Pi, whatever support package, and we do that. So that is this part of hardware integration. So we integrate with multiple different hardwares. I think many people might need C++ code from MATLAB algorithms. We generate the C or C++ code automatically for an Intel or ARM processor. The HDL is for Verilog if you are doing something on FPGA type of codes. That's what this is used. PLC, if anybody uses PLC for any the programmable logic circuit, we use that. CUDA is specifically for NVIDIA. And then there are other things like from here we can also create executable files, web apps, which is creating an app in the server. If you want to create a Python library out of MATLAB, so all these things can be done. So this is like once the algorithm is developed, how do we sort of share and make it go beyond, right? That is this part. Yeah, so this is an important aspect as well. Okay. Yeah, I think this is, I mean, we can go on, but I think I'll just summarize and talk of, I think typically what we were talking about is in that demo of the energy management optimization. We talked about MATLAB, SimScape Electrical is where it comes into. We talked about this tutorial, these courses. Just go to MATLAB Academy, that's where all these courses are. And we also have a lot of different courseware, like course materials, which we talked about as well. Some of them are there in MATLAB Drive, some of them are there in Git. So say for example, I'll show you this page, this is in GitHub. Say this is a virtual controls laboratory. What it contains is if I go down, you'll see like this is, say for example, talking about a vehicle model with cruise controls, the example that we talked about. So that example is there. This is an open public forum page. So you can anybody can download anything from here. So if you cruise control, DC motor, inverted pendulum, rotary pendulum, all these models are there. So this is about an application, project-based learning, you can call it, for controls. This is where it is. So there are multiple others. So controls is there. Then there are Fourier's, robotic manipulators, and so on and so forth. This page is in GitHub. It's called MathWorks Teaching Resources. Okay, so these are the models that are existing there as well. On that, for the students as well, we have something called a MATLAB and Simulink Challenge project. So this project list, this is like when we work with industry, we come up with some industry project ideas. So this list contains projects for different areas. So at AI, autonomous vehicles, there is one on Industry 4.0, one in sustainability and renewable energy. So you find out there are some. So this is actually over. This was a challenge that we were running, and actually we were monitoring this globally. And the first prize went to somebody from IIT Gandhinagar. So that's a good thing that it came out from India. So this is a renewable and sustainability challenge project that was running. So there were some problem statements, some on batteries, some on other wind turbines and stuff like that. This is over, but you can look into these other problem statements that are there. Say Industry 4.0 also contains some problem statements. So this problem, the thing that needs to be done is for the students to sign up for a problem. Need to have a faculty mentor, and we can also mentor them. There are different versions. There are some 4 months, 6 months. So this is not like a small hackathon time. This is more like a more extended thing. So it takes minimum of 4 to 6 weeks. So based on that, the details are all listed, how to get started, what to do, and stuff like that. So they have to submit an intent to do form, and then they have to submit the form and final submission. If anybody wants more details, let us know. We can discuss about this as well. Okay.
Can you provide this GitHub link?
Yeah. How do I provide the link here? That's what I'm. So you can just Google MATLAB Simulink Challenge Project GitHub. I think this should come up. If this is not coming, let me know. We can share. MATLAB Simulink Challenge Project GitHub. Then this should come up. Okay. Yeah, in the lab session you can check also in your computer. Yeah, I think for the MATLAB Simulink part, we'll take a short break and then we'll meet in the lab. And I'll also share some files that time through something called MATLAB Drive, so that you can download them, run them, play things on that. Okay, I think we'll take a short break and then.
Students, you can discuss now. And FDP participants will have a lab session. The venue is block. DSP lab.